This video is brought to you by Colliers Engineering and Design. Colliers Engineering and Design provides multidiscipline engineering, architecture, design, and consulting services to public and private clients. Their comprehensive suite of services offers everything from civil site development to transportation and energy through a nationwide network of offices. Colliers Engineering and Design values their employees and takes pride in their culture. With a focus on professional development and a family atmosphere, some of their offerings are a comprehensive mentorship program, a hybrid work environment, and competitive benefit packages. For more information about how you can join their team, find them on Twitter, Facebook, Instagram, and LinkedIn, or visit their website at colliersengineering.com.
It's not easy for us busy geotechnical engineers to keep up with industry trends while keeping up with our engineering work. Therefore, it is our goal that the Geotechnical Engineering Podcast can help you to do just that. We strive to keep our listeners informed on important industry topics and also to educate you on interesting technical topics and trends in the geotechnical world. In this episode of the Geotechnical Engineering Podcast, I'll be talking to Christina Tipp, PG, CEG, a professional geologist from SHN. Christina was previously on one of our other podcasts, the Civil Engineering Podcast, where she talked about the importance of geological engineering in civil engineering projects. And in this episode, she'll be talking about the overlap between geologic and geotechnical engineering and how being aware of this overlap can help you in your career. I'm your host, Jared Green, and I'm excited to bring you another episode of the Geotechnical Engineering Podcast. And with that, let's jump right into today's episode. All right, Christina, welcome to the show. It's great to have you here with us. How are you doing today?
Great. Thank you for having me. I'm doing good. How are you?
I'm doing well. So I've been looking forward to this conversation, and let's just get right into it. Can you tell our listeners a little bit more about yourself, and then also what is it you do on a daily basis?
Yeah, great. So I live in California and I have a professional geology license. And then I also ramped it up to have the certified engineering geology license, multiple bachelor's and master's, both in geology, because I can't get enough. And so I've used those my whole career in geotech firms. SHN is a larger firm, and we actually get to do a lot more consulting than I have at a previous company, but I've always been with geotechnical engineers and doing all sorts of consulting out in the field and writing reports and scoping out jobs, doing the drilling, jumping in test pits, all of it, all the paperwork, all the dirt work. It's all good.
Awesome. Did you always know you wanted to be a geologist?
I did. I think I made the call in fourth grade. I didn't know what I would be doing with it, but I couldn't stop picking up all the rocks. And then I grew up living close to the San Andreas Fault. So I have always wanted to do it, which has been to my benefit. I've always had a goal plan to at least keep carrying through.
That's so cool. And, most people think about geology, they think about field trips, being outside, right? All that good stuff.
Oh, camping, hiking, that also drew me in for sure.
Oh, that's awesome. Oh, that's really cool. So for listeners that might not be familiar with, I guess I'll say geological engineering, can you explain what an engineering geologist does? Like, what is a typical day? And typical might not be the right way to say it, but what's it like? Like, what do you do?
Yeah, so there's geology, but then when you want to take it up a notch and do engineering geology, we get called to look at things like we're going to start a quarry here out of this mountain. We need to know where the fracture planes are. Is there a fault through it? Anything that may, when they start digging into that mountain, is it going to fail on us? Is there an angle of the cut that we should avoid? And that's a good example. If subdivision going in somewhere, maybe there's a fault line map there, or they're inside of because we're in California, earthquake fault zone hazard area. So even if there's a fault line nearby, but not on that property, we'll get called to go and dig test pits and trenches and look for that fault line to make sure that subdivision or that school is not built on a fault line. lots of landslide projects, lots of mountains
Oh,
over here, and the random rain we get. So yeah, landslides, cuts, designing. I usually do the drilling for like liquefaction analysis too. Then we get that, do the analysis and the evaluation, get it to the geotechnical engineers for them to engineer. So I get to be the person who observes the sites and does the research. Like I'll pull any geologic map I can find up and see what have people found before, look at old aerial photos to see if there's a history of sliding or lineations that may be an indication of a hazard. Or yeah, so get to see the field and do the research and then put all those puzzle pieces together for development later or to keep people safe now.
that's awesome. That's awesome. And I guess during the exploration phase, like where you're drilling borings or you're excavating test pits, are you typically the one in the field as a geologist, or is that something that a geologist is looking at and the geotech is looking at? Like, how does that work?
Yeah, in my experience, it's always been me.
Okay,
So
got it.
I was taught to log borings by geotechnical engineers or engineers training to go that route. So
Okay.
I was taught by engineers and did all the borings. And then they knew that I knew what they were looking for, what samples they wanted, how to take care of those. And even now, I love the field work. Maybe I'm a micromanager, but I like to do it. And I always have my geotechnical engineer's voice in my head, like, what are they looking for? So
Okay.
I think I do a pretty good job at getting the field information and thinking about what they need for their analysis later.
Cool, cool. And you talked about like orientation planes for potential faults and things of that sort. Like, are you doing stereo nets? Are you using Bruntons? Like, what are you doing when you're in the field when you're mapping it? How are you
Yeah,
mapping?
so I always like to have some sort of base map, hopefully topo, but with all the drone footage now, like
Mhm.
you can get some cool maps from our drone group to map
Nice.
on. Yeah, so I'll go like the quarry job I was on, took my Brunton, did a bunch of measurements on the like dominant fracture planes and sets. And we also had shears through that. And we have a rock formation here that has a lot of old shears in it. They're not like no active movement, but it's
Okay.
still a plane of weakness that we want to make a note of that made daylight on the face of the cut. So we're doing measurements, combining all of that and putting it on the maps and then looking at the orientation that they may cut to see, yeah, what daylights. That's our biggest thing. What is daylighting? What is going to
Got it.
happen here? And there's so many computer programs we get to use now for yeah, you don't have to do stereo nets. There's
Okay.
programs for everything now. You just have to get the
Excellent.
data and put it in correctly.
Yeah, that's the big thing, putting it in correctly, right?
Mm.
And what about like do you find yourself doing like acoustical televiewer or optical televiewer or any type of geophysical methodologies, or not really?
Yeah, we had a highway job that we're doing and a significant amount of exploration, and they pull out the cameras and
Okay.
yeah, geophysics. It's not my expertise, but it was fun to be there and watch the people like who know what they're doing,
Yeah.
like do it. And I'm like watching the data and like this is cool. And all the cameras now. There's some things that I've done that now you don't like. I've been lowered down a big borehole to map, the
Wow.
slide. But now
Okay.
with all the cameras, they might not even do that anymore. I don't know because it's kind of dangerous, but it was
Yeah.
fun. Yeah.
Did you go down in like the cage, or I mean, that's how they do sometimes with these shafts, right?
Yeah, I think it was a 24-inch diameter hole. And I
Oh,
felt like in my mind, I was standing on a little wooden swing, but I know it was
yeah.
more, it was probably a cage, but it felt like a little swing and
Okay.
holding on. And then my
Yeah.
rock camera in the other hand.
Oh my goodness.
It was cool though. It was an old deep-seated landslide in the Santa
Okay.
Cruz Mountains of California, and you
Mhm.
could just see it was just a, a mess. Everything
Okay.
was mushed together. There was no discernible texture or bedding, and the
Yeah.
water was falling in there so quick. It was really
Oh,
cool. It's probably the only opportunity I'll ever get to do it, but it was
yeah. So
cool.
when they're lowering cameras down, you're like, well, I remember the way I used to do this.
Back in my day.
Exactly. Exactly. Wow. Well, if there's somebody that's interested in becoming a geologist, I mean, what are some of the things you would tell them? Like the experience, education, licensing. I know you have some advanced licensing. Like, what would you tell them? Like, how did they get
Yeah,
into it? How do they stay in it? What are some things they should be looking for? Looking for a program? What's some advice you could give for that?
great. Yeah, if you're already a rock nerd and want to do geology, go get a degree in geology, bachelor's. And there's so many jobs right now with just a bachelor's degree to
Yeah.
get you out in the field. You're going to be drilling. If no one told you that when you get a geology degree, you're going to be drilling at some point. So there's your warning. And I like it though. I love drilling. So I would say get your degree and then go out, get a job. It could be environmental, it could be geotech. There's so many geology careers right now. I was drawn to engineering geology. I like putting those puzzle pieces together and seeing it with my own eyes. I can understand that. I can put that together. But yeah, get that geology degree, get some experience. And then if you narrow down your field, you can go for a master's if that fits for you. But also finding a place to work with like a mentor or someone with an advanced degree to work with will be a huge benefit, to learn from them, ask them questions, and get a feel for if that's your right field. Because I know a lot of people switch fields later. I'm an exception to that, but like explore different companies or talk to different people. I always encourage people, like, maybe geotech wasn't for you, but try something else in geology before you give it up.
Awesome. And, can you tell us a little bit more about, you said you have the PG and then you have the CEG. Like what are some of the requirements? Like what kind of test do you have to take? And maybe what's the difference between the two?
Yeah, so for the PG, that's the first one you need to get. You have to have a degree in geology. I think the new requirement is you also have to take field camp with that degree. Some schools give you a choice, but I also highly recommend field camp. It puts the whole lower education together. So do field camp. And then I think it's 3 years experience with
Okay.
another PG. And then you can sign up to take the exam. And that's through the state. And then for the CEG, it's even more years experience, but with another CEG, and then take that
Hmm.
exam. So it all comes down to you have to have a geology degree and get the experience with a professional who will sign off and say they've done all this work and they support you in going forward with that license.
Excellent. So that's really good advice for those that are listening in. If you don't have somebody that has the PG in your company, you don't have somebody to sign off for you. And then the CEG, that's something else to look out for as well. All
Yes,
right.
and do field camp, people.
How long is field camp? How long is it?
Well, mine was 6 weeks, but
Wow. Okay.
I think they're changing that because that's a big commitment for people. So I think they might be doing more shorter, like 1 week here, 2 weeks there. But it was a really good experience for me. This, like, combining all the different classes into a few projects that you did together, and you do it as a group, so it actually mimics going to work because it's not all
Yeah.
solo work. It's working in groups. Not everyone's going to see the same thing and agree. So I got a lot of confidence after field camp, realizing I can put this together and my opinion's right, and we can talk about it. Yeah.
That's awesome. Those are definitely skills you're using in real life afterwards, right?
Yeah, the stuff that you don't always do in school. I mean, I hated group projects, but I like them now. I love the teamwork.
Yeah. That's great. That's great. And you kind of hinted at this a little bit earlier as far as how geologists work together with geotechnical engineers. But, for those that, we have folks that are listening in that may not have geologists on staff, like when should a geotechnical engineer be considering including a geologist on a project? And how do they work together? If you could share some of that, that'd be awesome.
Most of the time, CEGs are needed, and this is in California. I'm not sure of the laws in all of their states, but if there's a development is planned in any geologic hazard zone, so our major geohazard zones are landslides, so slope instabilities. Those could be shallow, they could be deep, very deep, large landslides, but if development's going on like hillsides in a sloping area, that's a hazard. We have lots of liquefaction hazard zones. So the valleys with shallow groundwater during a big earthquake, because in California, you can't avoid earthquakes. And then we have the fault line hazard zones. So any development going in like a known hazard zone, you're going to need a CEG for sure. A lot of the places I've worked, they wanted the geologist to do the field work anyway, and get out there and look around the site. Don't just look where the building is going or the bridge, like go wider. What other potential fatal flaws may you see? What do we need to think about? And apply those.
Cool. And during construction, is the geologist involved as well? Because I know a lot of times, the geotechnical engineer is providing some type of special inspection oversight, but is the geologist coming out as well to make sure that their recommendations were taken care of, or not necessarily?
Definitely. Yep. It's a combo. Okay. Sometimes there's engineers that I've kind of seen 50-50. There's some like engineers or engineer techs and geologists. Kind of depends. I haven't done that many of the site inspections later, but I usually, if someone needs a hand or needed some explaining about what the conditions were when I was out there, then we'll go do that. But yeah, we check in with the geotech engineer on all those. I also, during any exploration or report writing, I'm working alongside the geotech engineer like all times and double checking everything. We had a funny talk with our geo group, like, how do you explain like the difference? And it's kind of funny because geotechnical engineers and engineering geologists are two different fields, like different focuses and different education, but we end up in the same place, like writing the reports together. I think that's pretty cool.
It is. Yeah, because you look at things totally different, especially, I mean, you get through the overburdened soil and now you're into the rock and you're looking at it and you're looking at the same thing, but you're kind of looking at different things of it. The engineering materials and what it's going to take to rip through it. And you're looking at, well, when you rip through it, what's going to daylight? Do we have issues with fracture planes? So it's pretty cool when you think about it, that we're both looking at the same thing, but we're looking at it differently.
Exactly. And that's where I like the teamwork. Somebody may think of something that I didn't, or I'll see something and just report back and like, all right, what are we going to do about this now? And other people have some really good answers.
Yeah. It's like, oh, maybe I should consider that. Right.
Yeah. Yeah.
Oh, that's cool. Can you tell us a little bit more about, I don't know, interesting conditions or geologic features that you've encountered within your career?
Sure. Definitely being lowered down that big landslide. So that landslide, I think looking at cross sections and slope stability, we think it was 70 feet deep. We only made it to 40 feet because it filled with water and was caving in. So doing those large diameter boring, like logging them with the person inside, it's not the safest, and we were okay on that project, but that was pretty cool. I've also done a lot of fault trenches across like active fault lines, and that's always really fun. It's, to some people, they may just see dirt and, oh, there's brown dirt and there's gray dirt, but I usually see something new in every trench. There's some new feature that I haven't come across before, or the rock is stepping weird. One was in the Bay Area on a thrust fault, and when you got near the fault line, the rock lost all texture. It was sheared to mush, and it was colorful. And that's what really, you knew when you saw the color change on that one. But you couldn't even map a rock type in it. It was just completely sheared. And I still remember all those exposures are like still in my brain, so clear. So I love doing fault trenches and to see all the new features. Sometimes the rock isn't sheared at all, and you have that just that little fault plane. And then sometimes it's really wide zones that just got pulverized as the earth is moving.
That's cool.
Yeah.
And the fault trenches, that's where you have the bench slopes and you're stepping all the way down.
We usually just do straight down with shores
Ah,
in.
okay.
I've done like 14 feet deep is probably the deepest. We normally like to do like 8 or 10 feet
Okay.
because it's a lot of work climbing up and over the shores, climbing the
Yeah.
ladders, because we map the whole exposed space.
Wow. Okay.
And anything that pops out, we're trying to date the soil, any measurements we can do with our Bruntons.
Mhm.
Yeah.
Really cool. Really cool. Well, before we take our break, is there a final piece of advice you'd like to give our listeners? And again, we have geologists on the line, but we also have like a lot of engineers, a lot of geotechs listening in.
Ooh, yes. So I would say for senior engineers or geologists who are maybe sending out their entry level engineers and geos to like go drilling or do some field work, let them know what you're looking for and what you want from them and why that's important. Like, let them know what you're going to do with that data, not just ask them for it, because then they will collect better data and they will report back, and maybe the wheels in their head will start spinning a little bit more about why they're doing what they're doing and why it's important, and they'll just be better later. I was trained that way, so I think it was really helpful to just see the bigger picture, not just get your assignment and do it, to just understand more, and they'll be better out in the field and absorbing what's around them. So that's my advice.
That's great. Thank you for that. That's one thing that I've definitely heard people say is that they appreciate getting the big picture. It's like, this is your task, but this is the big picture. So that's really cool. That's really cool.
Yeah.
All right. Well, we're going to come back in just a minute and close this one out with Christina in our career factor safety in segment. Stick around. All right. Welcome back. It's time for our career factor safety in segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Christina Tipp, PG, CEG. Christina, you've already had a very successful career at a very young age. And when you look back at your career, what's one thing you've implemented to give yourself a factor of safety in your career?
Great. Well, thank you. And one thing that I've always been able to ask like a mentor or someone farther in their career than me for advice or to talk over a project, like I need that and I love that. So always having someone to talk to, find yourself a mentor. And even if it's not on a specific project, but just someone to talk things over with and look up to for advice, I think that's super beneficial.
That's awesome. Yeah, mentorship is crucial. It's crucial when going through our career. So thank you so much for that. Well, Christina, thank you so much for coming on, and thank you for sharing all the great insights with us and our listeners. You shared a lot of great information and advice. I know it's going to be helpful for them. If listeners wanted to reach out to you, what's the best way for them to get you? Social media or an email you want to share?
I have my LinkedIn account is all up to date, so you guys can take a look there, email me through there. I'll definitely respond. I try to update it with every class or webinar I take and all that. So yeah, any questions, anyone looking for a mentor, I'm happy to do that too. So reach out.
Excellent. Excellent. Thank you so much. That was great. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 42, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.